Let's look at some past questions on analytic geometry and calculus. We shall look at the one on the College of Distance Education at the University of Cape Coast. This was for the 2018-2019 academic year. We will first look at the objectives. So the first question number 1, objectives. We are to find the derivative of the function f of x is equal to x ln x. This is product rule. So we shall apply the product rule of differentiation. By the product rule, our f derivative of x will be equal to, first we'll maintain the x, then we'll differentiate ln x, and that will yield 1 over x. Then plus, this time around, we'll maintain ln x and differentiate the x, and that will yield 1. So simplifying, x times 1 over x will give us 1. Then ln x multiplying 1 is also ln x. So the correct answer is A. Then we'll go to the second question. We have to find the distance between the points A, negative 1, 4, and then B, 4, 16. We shall apply the distance formula. Let's label this one x1, y1, then here x2, y2. By the distance between 2 points on the Cartesian coordinate formula, the distance is equal to the square root of x1 minus x2 all squared plus y1 minus y2 all squared. We substitute in the values. So we have the square root of negative 1 minus 4 all squared, then plus 4 minus 16 all squared. So we are going to have negative 5 squared, which is 25, plus 12 squared, which is 144. This will yield the square root of 169, and that should give us 13 units. So the correct answer is D. Let's go to the next question. If the line joining the points 5, 3 and B, 10, T, and that joining the points P, 1, 3 and Q, 6, 2 are perpendicular, we have to find the value of the coordinate T. Good. So if they are perpendicular, it means the product of their gradient is equal to 1. So first, negative 1. First, let's find the gradient of the line AB. So the line segment AB, or the line AB, let's find its gradients. We shall name this point, the first one as our x1, y1, and the second one our x2, y2. Good. And we know the gradient formula. It is y2 minus y1, or changing y over changing x. So substituting the values, we'll have t minus 3 on 10 minus 5. And this will yield t minus 3 on 5. Then we find the gradient of the line PB. So gradient of PB, we will take the PQ. The point is PQ. So we'll take Q as our y1 s2. So this will give us 2 minus 3 on 6 minus 1. and this is equal to negative 1 on 5. The product of these two gradients will give us negative 1, or otherwise 1 is equal to the negative reciprocal of the other. So we can say t minus 3 over 5 is equal to the negative reciprocal of negative 1 over 5, which is 5. Then we can say t minus 3 is equal to 25, and then t is equal to 28. And then we seem not to have 28 in the options. Let's glance through our calculations and see whether there's some error. So let's first substitution. y2 is t, then y1 is 3. That's correct. Then we have 10. Take away 5. This is also correct. So that will be t minus 3 over 5. Passed. Let's come to here. The coordinate is 2 for q. So the 2 minus 3, correct. Then we have 6 minus 1. This is correct. This will give us negative 1 over 5. Good. It means the correct option is not in the options provided. So let's go to the next one. We are to differentiate the expression. This is an implicit function, so we differentiate as such. So the expression or the equation is 3x squared minus 2y squared is equal to xy. So when we differentiate term by term, so this will give us 6x, this will give us 4y dy dx. When we come to this guy, it's product. We differentiate using the product rule. So we'll maintain x and we'll differentiate y, and that will yield dy dx. This time around, we'll maintain y and we'll differentiate x, and that will be 1. Then we'll collect like terms. So we have 6x, then let's bring 1 dot y, which is the same thing as y, so become minus y is equal to x dy dx plus 4 y dy dx. Let's continue simplifying. X minus y is equal to, we factorize dy dx out, and we are having x plus 4y. Then we divide 2 by x plus 4y. So our dy dx will be equal to 6x minus y over x plus 4y. So let's see. And so the correct answer in this case is B. So B is the correct answer. 6x minus y on x plus 4y. The next question. The motion of a particle is given by the equation s is equal to 2t cubed minus 3t squared. And we are supposed to find after how many seconds that the particle stop momentarily. The particle will stop when the velocity is 0. So we have to find the velocity, and we know velocity is equal to the s over the t. So our v is equal to 6t squared minus 6t. 6t squared minus 6t. When the object is momentarily at rest, v is equal to 0. So 6t squared minus 6t is equal to 0. Factorizing t out, 6t out, we are going to have t minus 1 is equal to 0. This implies our t is either equal to 0 or is equal to 1 seconds. So in this case, our correct answer is A. So this question has already been solved. That is question 1 or so. So we can refer to that one. So the correct answer is A. We will not waste time. We have to find the distance. This is also a repeated question. So we had 13. Let's be sure. Yeah, it's 13. The same question that has been repeated. Then, so this is the question we didn't get the answer. It's also a repeated question. So answer supposed to be 28. 28. Good. Then find the equation of the line that passes through the point 2 neg 2 and is parallel to the line if equation x minus 2y plus 7 is equal to 0. So we have to write this equation in the gradient intercept form. Gradient intercept form. So let's turn the y 2y to the other side to become positive. Then later on we'll divide through by 2. So we have x on 2 plus 7 on 2 is equal to y. So it means the gradient here is 1 over 2. And since the lines are parallel, it means the required gradient is also 1 over 2. Required gradient is also equal to 1 over 2. In that scenario, we can use the formula for finding the equation of a line to find the equation. So we have half x minus the x coordinate is equal to y minus the y coordinate here, which is negative 2. So we are going to have half x minus 2 is equal to y plus 2. With clear fractions, by multiplying through by 2, we are going to have x minus 2 is equal to 2y plus 4. Then we arrange. So x minus 6, when the 4 comes, is equal to 2y. So let's see whether you have that option there. Okay. We have y minus 2x plus 6. So let's see whether we've missed something out. Y minus x is equal to 0. 3y plus 3, no. So the correct answer is also not provided. Let's see, when we divide through by 2, we are going to, okay, let's divide through by 2 and see. That one to get half here. Let me see whether it's a perpendicular line or find the equation of the line that passes through 2 and it's parallel. It's parallel. So we are using the same equation, the same gradient. Good. So it means the correct answer is not in the option, but let me not rule that out. Let me cross check again our calculation. So here we have x minus 2 for the x coordinate, y minus negative 2. So it becomes y plus 2. Then we clear fraction by multiplying through by 2. So we have 2y plus 4. When we collect like terms, we have negative 2 minus 4. That will give us negative 6. So 2y is equal to x minus 6. Grouping all at one side, we are going to have 2y minus x plus 6 is equal to 0. That one too is not provided in the option. You divide through by 2 to you have y half x plus 3. So the answer is not in the option. Let's move on. We have to find the radius of the circle defined by x squared plus y squared minus 4x minus 6y then minus 3. So we'll compare this to the standard form of equation of the circle, and comparing, we can see 2j is equal to minus 4 implies our j is equal to negative 2, and then 2f is also equal to negative 6. 2f equals to negative 6 and our f will be equal to negative 3. The center is minus j comma minus f. So this will imply our center will be 2, 3. So the correct answer in this, find the radius of the circle. Okay, we are finding radius. Good. So now that we know our j and our f, we can continue to find the radius. The center is not required. So we are finding radius, and the radius is given by the square root of j squared plus f squared minus c. Good. So the square root of our j is negative 2. So that will give us 4. Then our f is negative 3, that will give us 9. Then minus c, and c is negative 3, so that will give us plus 3. So when we sum these three numbers, we have 16, that is 13 plus 3, you are 16, and the square root of 16 is 4 units. So the correct answer in this case is C. What is the following? Which of the following is the turning point on the graph of the function? So we have to find the turning point. So first we must find the first derivative, f of x. Remember this quotient. So we use the quotient rule. We maintain v, that is the denominator, and we'll differentiate the numerator, and that will give us 2x. Then this time round, we'll maintain the numerator, x squared plus 4, and differentiate the denominator, and that will give us 1. So that is not necessary. We can decide not to write over the square of the denominator. That will give us x squared. So this will yield 2x cubed minus x squared minus 4 on x. Good. So at the critical point, a turning point, 2x cubed minus x squared minus 4 should be equal to 0. Or otherwise over x is equal to 0. And when it's equal to 0, the numerator is equal to 0. So we'll solve for the zeros of this polynomial function. We'll just use a calculator for it. So let me take my calculator simulator. So using the calculator, we'll go to mode, then we'll pick equations, then this is a cubic function, so we'll pick number 4. The value of a is 2, then the value of b is negative 1, the value of c is not there, that is the one we should have the coefficient of x. We don't have that term, so it's 0. Then the value of d is negative 4. So the 0 is 1.4 something. Let's see whether we are not doing something right, because we are not getting any values closer to these ones, these guys. We are not, because we have whole numbers there. So let's run through our differentiation, or let me see whether we have input the correct values. We have positive 2, negative 1, 0, and negative 4. Okay, for the values we have inputted the correct values. So let's see the quotient rule. We maintain the denominator, then we differentiate the numerator. So differentiation of the numerator will give us 2x. Then minus, this time around we maintain x squared plus 4, then we differentiate x. That will give us 1. Then we have x squared. Then opening bracket, we have minus x squared minus 4 over x. At the turning point, over x squared. I left the x squared here, even though that will not affect our calculation. At the turning point, dy dx is equal to 0. Okay, let's differentiate it in another way and see. Whether we didn't handle the quotient rule well. Well. Let's rewrite this fraction, split the fraction. So our function can be rewritten as x squared over x plus 4 over x, and this will give us x plus 4 over x. Good. Or otherwise x plus 4x to the power negative 1. Then we differentiate. So our f derivative becomes 1 plus, so here become minus 4x minus x squared. Good. So we equate this one to 0, and it's the same thing as 1 minus 4 over x squared is equal to 0. Current fraction, we have x squared minus 4 is equal to 0, implies x is equal to either 2 or negative 2. Let's do the quotient rule again. I don't understand why we are not getting the same thing. So that is the beauty of mathematics. So f of x is equal to x squared minus, is it minus or plus 4 over x plus 4 all on x. So we know this is our u function and this is our v function, and by the quotient rule of differentiation, our derivative of x, f of x, is equal to v dot du dx minus u dot dv dx all over v squared. Good. So we are going to have x dot 2x minus, okay, that is where the error is coming from. X dot 2x minus x squared minus plus 4 dot 1 all over x squared. So we are going to have 2x squared minus x squared plus 4, sorry, minus 4 all over x squared. Good. So we are going to have x squared minus 4 all over x squared. So when we equate this one to 0, we are going to get x squared minus 4 is equal to 0, like how we had in the previous screen. So I think the first calculation we made an error. So x is equal to 2 or negative 2. So let's look at the x coordinate. The one have 2 or negative 2. So we rule out all the others. A will be ruled out, C will be ruled out, and D will be ruled out. The only option that has a correct coordinate of x is B. So we'll go for the B. Good. Let's go to this one. Find the coordinate of the midpoint of the line joining the center of the circle and the point 11 and 9. So first we have to determine the center of the circle. So we know comparing 2J is equal to minus 2 implies our J is equal to negative 1. And then 2F is equal to minus 3 implies our F is equal to minus 3 over 2. So our center will be equal to negative, so it becomes positive 1 comma positive 3 over 2. Then the midpoint between these 2 points, the center and the point, can be calculated by using the midpoint rule, s1 plus s2 over 2 comma y1 plus y2 also on 2. So let's drop in the coordinates. We have 11 plus 1 over 2, then 9 plus 3 on 2 over 2. So the x coordinate will give us 6. And we don't have 6 in the x coordinates. So let's be sure. are doing the correct thing. Find the coordinate of the midpoint of the line joining the center of the circle and the point 11, 9. So let's see, 2j is equal to -2, and then our j is equal to -1, correct. So 2f is equal to -3, and our f is equal to -3 on 2. So the center is 1, 3/2. So by the midpoint rule, we just add the s coordinate and divide by 2. So we have 1 plus 11/2, and that should give us 6. We don't have 6 among the options, so I can rule out that the answer is not there. But let me be sure again. Let me add this one. Let's add this one and see what we have. So 9 plus, let's go back and do the addition. 9 plus 1.5, which is the 1/5. 3/2 is this. Then we divide our answer again by 2. That's 21/4. So this is what I'm having, but it's not part of the options. But let's go through once again. So x squared plus y squared minus 2x minus 3y is equal to 0. So 2j is equal to -2 implies our j is equal to -1. And 2f is equal to -3 implies our f is equal to -3/2. So the center is 1, 3/2. And we are finding the midpoint between the center and the point 11, 9. 11, 9. So 11 plus 1 is 12 divided by 2. So I can rule out. So there's no option, no correct answer within the option. No answer here. So let's move on to question 13 quickly. We are far behind time. The point of inflection on the graph. So the point of inflection, the second derivative is equal to 0. So first, let's find the first derivative. That is 12x cubed minus 12x squared. Then second derivative. Let me see whether you are doing it right. 12 cubed, 12 squared. Okay. Second derivative is equal to 12 times 3 will give us 36x squared minus, this will give us 24x is equal to, okay, we'll get it at the second stage. So let's leave this one for the meantime. So this is the second derivative. At the point of inflection, this is equal to 0. So 3x squared minus 12x is equal to 0. That's solved by factorizing. We'll factorize, I think, 12 out, 12x out. So when 12x comes out, here we'll have 3x, but here we have 2 is equal to 0. So it's either 0 or either s is equal to 0 or s is equal to minus, so 3x minus 2 is equal to 0 implies 2/3. S is equal to 2/3. Good. So this one, in order not to waste our time, when s is equal to 0, y is equal to 0, the function will also be equal to 0. So the correct answer in this case is A. 0, 0 is a point of inflection. We are integrating this function from 0 to, this is an objective question, so let's learn how to do that with a calculator. So we come here, you press this key, and you program the function. So it is 9, then alpha, close bracket to get your x. You put the square on top, then take plus 3, then we navigate. I should have put these things in bracket. That is the best way. So let me navigate back and put these things in bracket. Then let me put in the limit from 1, then lower limit is 0. The answer is 6. So using calculator, the answer is what? 6. So that's C. And let's go to this one. Good. You have to find the direct x of the parabola defined by the equation. This direct x is not part of our, may not be part of your course, but once it's there, let's do it. In fact, the equation is already written in the standard form. For you to find it, in the standard form is x plus h all squared is equal to 4p into bracket y minus k all squared, y minus k. So comparing this to the expression, we can find the values of h, p, and k. So minus h is equal to 3 implies h is equal to minus 3. Then 4p is equal to negative 2 implies p is equal to 4 minus half. Then minus k is equal to negative 1 implies k is equal to 1. The direct x can be found. This is a parabola that opens up or down. You should take note, we have a parabola that opens up or down, either this way or that way. Good. In that instance, the equation starts with the x plus 3, x plus h or x minus h all squared. If the parabola opens this way or that way, that one, it will be of the form y minus k all squared is equal to 4p into bracket x minus h. But we are not referring to that side. That's just by the way. So the direct x is given by the formula y is equal to k minus p. Since we know our k and our p, that will not be a problem. Our k is, in this case, is 1 minus our p is negative what? Half. So minus half, that will give us 1 and half, so 1.5. So the correct answer in this case is D. So we'll take note of that. Then the focus of the eclipse, whose equation, this one too is the same thing. It's not within your domain, but once it's here, let's look at it. So we have to write this in the standard form, which is x minus something squared. Let's say minus h squared, then over b squared plus y minus k squared minus k all squared over, sorry, this is a over b squared is equal to 1. So rewriting this in that form, you can write this as x minus 0 all squared over 3 squared, then plus y minus 0 all squared over 5 squared is equal to 1. So the equation, our center will be 0, 0 as the center, and the focus is 0 plus comma, then our h here plus c, and the c can be obtained by using the a and b. C is equal to the square root of a squared plus b squared. So c is equal to, our a squared is 9, you can see from the equation, and our b squared is what? 25. So that is going to give us 9 plus 25 is No, it is actually b squared minus a squared. B squared minus a squared. So let's clean that. Let's clear that. It's b squared minus a squared. In fact, whichever is bigger. So the bigger one always. So if a was also bigger, would have made it a squared minus b squared. Good. So b squared minus a squared in this scenario. So 25 minus 9, and that'll give us 16. I'll see before. So 0, comma, then our h here is 0. So 0 plus 4. In fact, the actual focus would have been plus or minus c. So let's take note of that. Plus or minus c. Plus or minus c. So this will be 0, comma, then plus or minus 4. So this will translate to 0, comma 4, 0, comma negative 4. Good. So the correct answer in this case is A. Is A. So A is the correct answer. Good. So we have to find the parametric equation for the Cartesian equation. So this is the Cartesian equation. So we are converting it to parametric equation. I think this one too is not within your domain, but let's do it. To convert it to parametric equation, it is x is equal to a sec t, then y is equal to b tan t. So what you need to do is to determine a and b, like how we did with the first one. This one have to be rewritten in the standard form. So this is x minus 0 all squared over 4 squared, and then y minus 0 all squared over 6 squared is equal to 1. So this is our a and this is our b. So it means the answer is x is equal to 4 sec t, and then y is equal to 6 tan t. The correct answer in this case will be D. Let's look at this one. Find the equation of the tangent to the parabola x squared minus 3y squared plus 3 is equal to 0 at the point 3, 2. So the tangent of the parabola will have the same gradient at the same point of the parabola. So we have to find the gradient function. So x squared minus 3y squared plus 3 is equal to 0. We differentiate the function, get 2x minus 6y dy dx. Then the differentiation of the 3 will drop, is equal to 0. This implies 2x is equal to 6y dy dx. Then we make dy dx the subject by dividing through by 6y. So dy dx will be equal to 2x over 6y. Simplifying further, dy dx is equal to x over 3y. So gradient at 3, 2. So let's calculate gradient at 3, 2. Gradient at the point 3, 2. Remember our dy dx yielded x over 3y. So we just substitute in. So this will be 3 over 3 multiplying 2, and then that will yield 1 over 2. So we are only finding the equation of the line with gradient half and passes through 3, 2. So that 1 over 2 into bracket x minus 3 is equal to y minus 2. Then with clear fraction, x minus 3 is equal to 2y minus 4. Collect like terms. X, this will come here to become plus, and that will yield positive 1 is equal to 2y. So 2y is equal to x plus 1. So we should expect something like this or its equivalent. Let's see. We're not getting anything like that. So let's quickly glance through our calculations and see. Find the equation of the tangent to the parabola. X squared minus 3y squared plus 3 is equal to 0 at the point 3, 2. So let's start with the differentiation. So this is 2x, then we have minus 6y dy dx. Differentiation of 3 is 0, and 0 is still 0. So we have 2x is equal to 6y dy dx. Dividing through by 6y. 2 go into 6 3 times. So we have x over 3y. Then the point is 3, 2. So we substitute to find the gradient. So 3 on top, 2 down. Cancelling out, we have 1 over 2. Then we are using the same point because the tangent passes through that point. 3, 2, so it will be x minus 3, y minus 2. Clearing fraction, we have 2y and then 4. Collecting like terms, so I'm not sure the correct answer is inside. So this is not the correct answers. None of them has a correct answer unless otherwise there is something that is omitted in the question. Find the equation of the tangent to the parabola. So the correct answer is not there. Then we are finding the equation of the normal at the point 1, 7 to the curve. I think this is supposed to be x squared. So the curve is y is equal to x squared minus 2x plus 1. Good. So we have to find dy dx. So we have 2x minus 2. So this is the gradient function. So at the point 1, 7, our dy dx will be equal to 2 multiplying 1 minus 2 minus 2. So that will be 0. So it means the gradient is 0. If the gradient is 0, that means the line is perpendicular. Sorry, it's parallel to the x-axis. The tangent is parallel to the x-axis. And if its tangent is parallel to the x-axis, this will imply the line, that the normal will also be parallel to the y-axis. And any line that is parallel to the y-axis has the equation s is equal to a, where a is constant. And we don't have such. But let's quickly glance through the calculations again. X squared minus 2s plus 7. So we have x squared minus 2s plus 7. Okay, root 1 here. But that will not affect our calculation. So the y dx is 2x minus 2. So the gradient function is also correct. Then, since we are looking for the equation of the normal at the point 1, 7, we first have to find the gradient at the point 1, 7 by substituting the x coordinate into the gradient function, and that will yield 0. 0 implies that point 1, 7 is a turning point to the curve. It's a turning point to the curve. Good. Let me even see whether 1, 7 satisfies the equation. Y is equal to x squared minus 2x plus 7. No, it doesn't satisfy the equation. let's see. Okay, but let's throw in and see. So 1 squared minus 2 times 1 plus 7. So this is going to give us negative 1 plus 7, which is negative 6. So there's either a problem with the equation or the point provided is not correct, because the point is not on the line. It doesn't satisfy the equation of the line. Good. So that ends the objective part. We're moving on to the section B, but I'll do that on a separate video.